Okay, so this video is, we're going to call it, for all intents and purposes, 1.3b for Math 8, of course. So that's 1.3 continued. We're solving equations with variables on both sides. You might remember that in the last video, we did these problems here, and we did the answer. We got the answer to 1, and we get the answer to 2. I'm sorry, we get the answer to 1 and we get the answer to 3. They're right there. And now we're going to actually skip up in this sheet. So unless I've corrected the worksheet, this is what we're going to go to. So make sure you're tracking with this. I think you're going to have to go to the top of the page to work on this one. And now we got to work on this problem. We got to think about it for a second. So what I'd like to do is I'd like to circle the things that are constant terms. And I'd like to box the things that are not. And I'd like to move either so that all the blue boxes are on the left and all the green circles are on the right. There's a couple different ways you could do it. You could actually put the green circles on the left and the blue boxes on the right. Whatever you want to do, collect them all to one side. So if we were to do that, we would have to add 4x here to cancel this out. Okay, add 4x. So we're adding that. That's canceled. So what happens is when that happens, you're left with nothing over here but 3, and you're left with nothing over here but -7. And you say, wait a second, my variables are gone. That's weird. They're totally gone. And this doesn't make any sense. And when you have an equation that's not equal, it means that your equation was no solution. It's not possible. There's no number for x that could make this work. No number that could make this work. So no solution or just a 0 with a slash through it is fine. However you want to write it is fine. So no solution is the answer to this one. Okay. So let's go through another problem or two. So we got this problem. If we go back to our steps, what we need to do is we need to multiply here and here. So let's try to solve this problem. So 6x plus 4 is here. That's fine. And now distributive property says, well, I'm going to make this 4 over 1. And that's going to make this 12 over 2. If you look at this right here, top times top, bottom times bottom. So 12 over 2x, which is really 6x. So I'm just going to go ahead and show this, okay? And now the 4 is going to go to there, and it's going to be a positive 4 when I distribute here. So let me show you how I got this number. I did that loop, 4 times 1. So what you'll notice is that you have an equation that is exactly the same on the left as it is on the right. So let's look at the left side for a second. Okay, there's that. And let's look at the right side for a second. There's that. Is the yellow highlighted and the green highlighted the same thing? Yeah, it is. So you can either call it a day and write the infinity symbol or infinitely many solutions, right? Which is fine. Or you could say all real numbers. That's another way to look at it, all real numbers. Or you can actually keep trying to solve. If you keep trying to solve, you're going to find something interesting. Well, if we look back at our groupings again, and we call this our, constant term, this is our variable term, and our variable term. And we try to collect the variable terms. We move over the 6x by subtracting it on both sides. We now have nothing there. We just have the 4 is equal to 4. Now think back for a second on the last equation here. And what happened when we had 3 is equal to -7? In this situation, we said it was no solution because it doesn't equal. But here in this situation, it does equal. So 4 equal 4 is a true statement. That's true. And that's what makes it infinitely many solutions or all real numbers. What does that mean? Well, all real numbers means that no matter what number you pick, okay, it should be able to go into this equation and work. So let's bubble that equation in purple so we can kind of take a quick look at it. And I want you to pick a number. I don't care what number it is. So you pick a number, I'm going to pick a number, but you pick a number in your head, okay? Let's go ahead and think about that for a second. I'm making my bubble here. Okay, so I picked for my number -2. So I'm going to put -2 in, and I just picked that out of nowhere. -12 plus 4, and then I'm going to have equals 4 times, well, if this is -2, these are going to cancel, but we're still going to have that negative sign. So we're going to have 4 times -3 plus 1. Okay, So looking at this for a second, okay, let me erase some of these things that are in the way. So I now have -8 from this, right? And then I have -12 plus 4, which is -8. So it worked. Yeah, I guess x is equal to -2 is an answer. But if you had said x is equal to 5, would that have been an answer as well? And the answer is yes. Any number that you put in for x, any number that you put in for x will make this equation work. Okay? So that's where we're at right now. So feel free to stop it, rewind it, whatever you got to do. We're getting down to the end here. Two special cases, infinite solutions and all real numbers. Also, or no solution at all. So if we look at these problems here, and we don't focus on this problem for a second, because it's just a little bit daunting, it's just a little bit overwhelming what's going on with that equation. I want you to try, basically I want you to try numbers 5 and 7. I'm going to do 4 for you, but now you try 5 and 7 in just a moment. So I'm going to put NYT, that means now you try. Okay, it's something you'll start to see a lot as you do this. Now you try, now you try. So I'm going to do this problem real quick. I'm going to box this, I'm going to box this, I'm going to collect all of these by moving them. So subtract on both sides, that's gone. Well, what do I have left? I have +1 is equal to -1. Is this true or is this false? Because this is false, the answer is no solution. You can write out the word no solution, or you can just put that little symbol there, which means null, which means nothing. There isn't anything. And it doesn't mean the solution's 0. So pause the video, try 5 and 7, and then I want to show you one more thing that's important. You'll put it in the margin. Be sure if you're watching this video at home that we go over 5 and 7, or at least get the answers, because I'm not going to put them up right now in class. So that's something to think about. So the last thing I want to do is I want to show you a problem like this. 2x plus 5 is equal to... So I've changed my mind. So what we want to do now is we want to just write down everything that's not changing, okay? Let's collect the x's to one side. I should have put the plus in there, but that's okay. So subtract 8x, subtract 8x. You could have done either one. You could have moved either one, but I like to put my x's on the left side. I know a lot of you agree with that. You feel the same way. So this is where I'm at right now. And don't remember, you don't have this problem written, so you don't want to put this in the margin, okay? So make sure you have that problem in the margin somewhere, in some space. And now I want to solve this, and I want to, let's see, well, we usually circle these. So I'm going to subtract 5, I'm going to subtract 5. So I'm going to have the following. Well, over here I'm going to have 0. And over here I'm going to have -6x. And you might say to yourself, oh, it's no solution, or if it's infinite solutions. A lot of students say that. But it's actually not, because how could you still get the x alone? There's actually an x here. That's the key. And because there's an x there, you can actually divide by -6 on both sides. And when you take 0 and you divide it by -6, your answer is 0. So sometimes when the answer is 0, seems kind of weird, and it mimics, it looks a lot like the no solution or the infinite solutions, but it's not. So when the solution is 0, don't be fooled, okay? That's something to be aware of. When we look at these two circles, right, and they say these circles are identical, what's the area? I want you to try this one more problem. This is a tricky problem, and I'm going to put NYT for now you try. And also, you should have some space on your problem, so try this problem as well. Pause the video, give it a shot, and then we will kind of come in and go over that in class tomorrow. Okay, so pause the video, try this problem. Don't forget to put everything that's necessary there, because I know what I'm expecting, and it will be checked tomorrow in class, most likely if you're in my class, and I will see you soon.